Hello again, and in this final video where I'm showing how to factorize trinomials with leading coefficients not equal to 1, I've got a formula that we're using, and this formula has been proving to me at least very useful. This time I want to just show you something a little bit different type of example. In this one, it's actually possible and advised to first take out a common factor. Here, for example, you might see that you can take out a 5 as a common factor out of each of these terms. But let's say you didn't see that. What's very nice about this formula is, in the end, if you continue with the steps we've shown you, you still should be able to factorize completely without even recognizing to start with taking out a common factor. Let's start using our formula. So it's 1 over 4 times a. A this time is 50, so it's going to be a massive number, 1 over 200, but not nearly as big as what we're going to get inside here. 2 times a is therefore 100x plus b is 145. Okay, and now we have this square root of b squared minus 4ac. So let's just do that as a calculation here. Okay, so we have b, that's 145 that's being squared, minus 4 times a, which is 50, times c, which is 50 again, and now we get the answer, 11025. This must be a square root or a perfect square. If it's not, then this thing can't factorize into 2 brackets. See? Ha! What do you know? It actually is 105, so plus 105. And that's it. That's all the difficult parts, because this bracket looks exactly the same, except that very last term is a negative, a different sign. In this case, this should have actually been the negative, but it doesn't matter which one you make negative, so I'm not even going to bother changing it. As long as the one has the last term as positive, the other one has the last term as negative. 105. Okay, so we get 2 terms here, and I'm just going to write it up here, because hopefully you will be able to just do most of this on your calculator and immediately just write the 2 brackets that we're going to factorize further. This 105, that gives me 50, that gives me 250 for this term, and this one gives me 145 minus the 5 minus the 100, that gives me 40. Okay, so now what I need to do is I need to take out the biggest common factors from the 2, and hopefully you can see that you can take out a 25. It's maybe difficult for some people to see, but if you take out a 5, you'll see you can take out a 5 again, so you're taking out a 25. If I take out 25 from here, I'm left with 4x. 25 goes 4 times into 100, plus 25 will go 10 times into 250. Okay, so I've taken out a 25, so 25 is now up here, 25, and then from this one, 140. So you can take out 20, yes, you can take out a 20, that's it. If I take out 20 from here, I'm left with a 5x, okay, that's taking out a 20, plus, and if I did this correctly, it's taking out a 5, is that 40? Yes, plus 2. And then finally, we have taken out a 20 here, so in total, we've taken out 25 times 20. So 25 times 20 is 500. So we're left here with 500 over 200, or 5 over 2. And now I notice, oh, wait a minute, this is a little bit of a problem, because I don't want a fraction in front. It shouldn't be a fraction, it should be a whole number. And then I actually didn't see that, but I haven't completely factorized this one. We can still take out a 2. As long as you have a denominator here, you haven't completely factorized, or you made a mistake somewhere else. So I can take out another 2 here, and that's going to cancel with the denominator. So it will cancel if I take out the 2, and I'll be left with 2x plus 5x plus 2. There we go. And notice if we multiply this out, for example, the first terms is 2x times 5x gives me 10x, and then when I multiply that 10x squared, when I multiply that with 5, I get the 50x squared. In the middle, I get 5 times 5 is 25. 25 plus 4x, 25x plus 4x is 29. When I multiply 29, I get 145. And the last term, 5 times 2 is 10. And that 10 multiplied by 5 gives me the 50. So there I go, using my formula to completely factorize what would actually take at least double the amount of time using the cross method, in my opinion. Maybe you're good at the cross method. I definitely am not. So I'll see you around. Thank you for watching.